in our third example of right triangle trigonometry word problems, we have a ladder leaning against a wall and making a 60-degree angle with the ground. The base of the ladder is 3 meters from the building. How high above the ground is the top of the ladder? So we're basically figuring out how tall the building is that the ladder is leaning against, right? So, as usual, I'm going to give you a couple of seconds. I'd really, really love it if you would pause the video and give this a shot on your own. Notice that this one does not give you a diagram. You'll have to make your own. Ready, set, go. Okay, so we've got a wall, and I'm actually going to draw a wall, even though you don't really have to. You can just make it an up and down line. That's totally fine. So there's my wall, and we have a ladder leaning against that wall. Ladder. Shut up, I'm an artist. And it says that the distance from the ladder to the wall is 3 meters. And it says that the ladder makes a 60-degree angle with the ground. So which one of these angles, think about it for just a sec, which one of these angles is it talking about when it says it makes a 60-degree angle with the ground? There's a 60-degree angle. And the question is, how high above the ground is the top of the ladder? So we're looking for this height. Now, there is one very critical assumption that we're going to make here that the problem doesn't actually say. But if it's a wall, if it's a building that was made by competent builders, we can assume that this is a right angle. It's a wall that's going straight up. This isn't the leaning tower, or else the problem would have said so. Now, in the last two examples, we needed to use SOHCAHTOA. We needed to use those ratios for the last couple of examples, and that works here. We can totally set up SOHCAHTOA, and we can solve it out that way. But I think there's an easier way. Think about it. Take a look at this triangle. There should be something very familiar about this triangle if you've been watching my videos. There should be a link up there right now to remind you if you forgot. So yes, SOHCAHTOA will work. We could use, it looks like tangent again, because we've got the opposite leg and the adjacent leg. So we could totally do tangent of 60 equals h over 3, but I think we can do I think we can do this an easier way, okay? Because this is one of our special right triangles. This is the 30, 60, 90 triangle, right? If that angle is 60, the other angle, the small angle on the top, must be 30 degrees. Now, if you have your notes out about 30, 60, 90 triangles, and you really should have your special right triangles just like on a piece of paper next to your desk, because you'll probably see them a lot. We remember, I hope, quick review, that when you have a 30, 60, 90 triangle, that's awful. Let's try that again. If you recall, whatever the short leg is, the hypotenuse is 2 times the short leg, and the opposite side is the short leg times the square root of 3. Again, if you don't remember that, that's normal. It should be in your notes. You should not be, I mean, you can memorize it if you want, but it's not necessary. So in our ladder example, we have the short leg across from the 30-degree angle, and that's 3 meters. So that means that h is going to equal, well, in a 30, 60, 90 triangle, the long leg is the short leg times the square root of 3, so it's going to be 3 times the square root of 3. And if we want this is a word problem, this is a practical application, so a rounded off decimal is definitely appropriate. Hey Google, what is 3 times the square root of 3?
The answer is approximately 5.196152.
5.20. And that's our answer. Oh, meters. So our answer, remember, this is a word problem. If someone asks you a problem or a question in words, you're going to answer in words, not in mathematical symbols, right? So you would say the ladder goes 5.2 meters up the wall. Smiley face. Purely by accident, by the way, we also figure out that the ladder is 6 meters long, right? Because again, the hypotenuse is always twice the short leg. So if the short leg's 3 meters, the hypotenuse is 6 meters. I really hope that made sense. Again, you would still get the same 5.2 meters if you use tangent, and I do encourage you to try this problem again using tangent and see if you get the same answer. Because I want you to see that these two different methods are both appropriate. They both work. It's just that the special right triangle method is a lot faster than the trig ratio SOHCAHTOA method. They are both valid. They both work. But it's important to know both because, I mean, theoretically, I could turn a wrench sideways and use it to hammer in a nail, right? But that doesn't mean it's the right tool for the job. Anyway, that's it for me for now. Thanks very much for watching, and class dismissed.